critical angle. It is the angle of incidence at which the angle of refraction becomes 90 degrees. Particularly if you are going to have a observation, so you can increase the angle, and at a particular angle you will get the angle of refraction 90. Let us see, if you are going to look into the picture, so the water and the air surface, the light rays are emerged from the water surface. See, you are going to incident the light rays from water medium to air medium. Let us see what happened. At a particular angle of incidence, the angle of refraction, it is going to be 90 degrees. It has been refracted with respect to the boundary surface at 90 degrees. See that. Yes, have a look. That is, we have incidented at 28 degrees. Yeah, this is the case. Yes, please have a look. First case, we have incidented the light ray at particular angle. It is refracted from water medium to air medium, that is denser to rarer medium. So, whenever a light rays are going to be refracted from denser to rarer medium, you have to observe that the refracted ray moves away from the normal. So, let us assume this is the normal. So, moves away from the normal. Here the angle of incidence is less than that of angle of refraction. It has been refracted at angle of 35.7 degrees. That is very clear. Second case, you have been incidented the light rays, simply you are increasing at a particular value, you will get that angle of refraction, it is 90 degrees with respect to the normal. This is the normal. Please take this one. So, it is very clear, gradually increasing the angle of incidence, at particular incidence you will get that refraction becomes 90 degrees. It is very clear. Now, let us have another case. Further you are increasing the angle of incidence. Further you have been increasing the angle of incidence. So, it is totally reflected. It is totally reflected into the same medium. That is, here you can confirm, that is, angle of incidence is equal to angle of critical angle. So, here we can confirm that, here we have to confirm, we have to confirm here theta r. So, theta r, angle of refraction becomes 90 degrees. In that case, the incident angle is nothing but critical angle. Yeah, for this case you have taken 48.75 degrees. You have been observed, in case of glass material, you might be having that 41.8 degrees. In case of the diamond, you might be having that 24.4. So, for every material there is a one critical angle. It is depending on the density, nature of the material. So, critical angle is different for different materials. In this case, we have seen water, that is observed 48.75. So, in this case what happened? Theta I, angle of incidence, is greater than angle of critical angle. Now, in this case, theta I is less than theta C. theta I is less than theta C. What happened when you have been incidented the light rays less than critical angle, greater than critical angle, at critical angle, the angle of refraction becomes 90 degrees. Here the total internal reflection takes place. The incidented ray, this is the incidented ray, this is also the incidented light ray will be reflected into the same medium, that is the total internal reflection. Based on this principle, the optical fiber communication was possible. So, with the help of this total internal reflection, the information has been carried with the help of light waves at high speed. The light rays are limited to the same medium, that is, generally optical fibers are equipped with the glass which is act as a core material. So, it will goes at high speed and after each and every multiple reflection. So, this is the case what we have studied, light incident at different angles, denser medium to rarer medium. From this picture what we have observed, if we have incidented less than the critical angle, at critical angle, greater than the critical angle, what happened we have seen, right. Now, let us go for another observation also. Yes, we have taken air glass interface. We have incidented that this is the case. We have to observe that this is the case, theta C, theta I is equal to theta C. So, the incidented angle is equal to critical angle, then there exists a angle of refraction 90 degrees. We can see the crafted light rays in different colors, that is, you can observe easily this is the angle which refers to critical angle, that is, you will get that. Yeah. Now, if you are identify this one, this is total internal reflected light ray. So, the light rays are limited to same medium after reflection. The light rays are entered from one medium to another medium after refraction. So, easily you will find out that reflection is the phenomenon which is related to the same medium. So, the light rays are limited to the same medium. Refraction is the phenomenon which has been extended to another medium, that is, refraction, it is the phenomenon which is identified with the help of two media, that is, rarer to denser or denser to rarer. So, finally, reflection was related to one medium or same medium, refraction related to two media, that is the case we have to identify that. So, now you can take that, yeah, it is critical angle. Suppose if you are going to identify the critical angle for different materials, it is having different value. Easily you will find out that critical angle for any material, but how it is possible? So, we have to incident the light rays at different angles. At a particular angle you will get the angle of refraction 90, that is the special case, you have to identify that. Now, please have a look, is the angle of incidence in denser medium for which the angle of refraction in the rarer medium is 90. Please take that. So, this is even boundary between the two media, a transparent boundary. So, this is the normal, this is the incident light ray. If the incident light ray is going to having the angle which is equal to critical angle, then you will get the angle of refraction is 90 degrees. So, this is the 90 degrees, yeah, what we have obtained, that is 90. So, we will consider this theta c is 90, theta c is going to get that at 90 degrees you have to consider the angle of incidence is nothing but critical angle for that given medium. Yes, please have a look, that is angle of incidence I is equal to IC. This is the critical angle you have to identify. Critical angle. So, this is a general representation of the critical angle for any two media having the different refractive indices. So, denser to rarer, the case we have to consider denser to rarer. The light rays are going to be entered from denser to rarer. We can take the set of two media, that is water, air, glass, air. So, we have to consider, if you are going to look into the matter of glass and water, so glass to water, as compared to water, glass is the denser medium. So, we will confirm. So, due to the flexibility of this combination glass and water, the optical fibers are immersed and installed in the deep sea basin. So, optical fiber comprises the glass material which supports the total internal reflection. So, the installation process is very simple in the sea basin. So, the optical fibers are laid down from one country to another country with the help of sea basin. So, we are having the sea basin and we have connected with the optical fibers. So, the maintenance and communication is very easy when you have been placed the optical fibers in the water medium. So, which supports the total internal reflection. Yeah, that is the case in general observation. So, this is very clear, we can confirm. Now, if you are going to take that in the denser medium, you may consider water, air, glass, air, you may consider glass and water. So, that is special, you can confirm. So, if you are talking about that theta c, critical angle, so it depends on temperature, depends on temperature. Temperature and nature of medium. Yeah, theta c is different. It is different for different materials. For different materials. I hope so you have the good observation with critical angle. So, for every material it is possible to calculate the critical angle by knowing the refractive index of that material and the speed of light in that material. So, easily we can calculate. Now, we will go for that relation. So, theta c depend on mu, that is refractive index of the medium. Theta c is going to have the relation between mu and nature of medium and that angle of incidence, we have to consider these two parameters. So, if the temperature increases, what happened? Let us see. The temperature of a transparent material is going to be changed, then its critical angle is going to be changed. How it is possible? So, as the temperature increases, that the refractive index is going to be changes. It is going to be decreased and the critical angle is going to be increasing. That is the case. So, easily you will identify that the temperature increases, what happened? The density is also changes and the speed of light is also affected. So, these are all the internal related parameters. Please have a look. Let us go for the derivation. Yeah. Now, you can confirm that relation between critical angle and the refractive index of the medium. And refractive index. Yes. Now, you are going to apply Snell's law. So, according to the Snell's law, the ratio of sine of angle of incidence to sine of angle of refraction is going to be constant, which represents the ratio of the refractive indices of the two medium. That is mu 2 sin I by sin r is equal to mu 2 by mu 1. Yeah. So, that relation is sin C is equal to 1 by mu. This is the relation. Yeah, how you can obtain this relation? By applying the Snell's law to the denser rarer medium interface. So, please have a look. Yeah, this is the case. We are going to take that interfacing surface. Now, this is the first medium, this is the second medium. So, this is the denser medium, this is the rarer medium. Light enters from one medium to another medium. So, there exists a change in its direction. Whenever you are considering that the light is going to be incidented, it is the incidented light ray which is having that theta c. Theta I is equal to theta c. Then the angle of refraction, it is going to be theta r is equal to 90 degrees. Yes, please have a observation in two media which is allowing the light rays from denser to rarer. We are incidenting at a critical angle. The light ray is going to be refracted at 90 degrees. This is the normal. Yeah, we are going to take that. Now, let us assume this is the air medium, this is the denser medium. So, we are going to confirm this is mu 2, this is mu 1. So, the refractive index of the denser medium is mu 1, refractive index of rarer medium is mu 2. Now, apply Snell's law. You have to apply Snell's law. apply Snell's law to, yeah, that is you are applying the Snell's law to denser rarer medium. Denser rarer medium. Yeah, that is. Now you can start with the angle theta I mu I, that is mu 1 sin theta I is equal to mu 2 sin theta r. It is very clear. Now you have to look mu 1 mu 2, I have the relation mu 1 is greater than mu 2. Now at theta I is equal to theta c, yeah, at critical angle the angle of refraction becomes 90. At theta I is equal to theta c, theta r is equal to 90 degrees. Yes, that is the case. So please identify this. This is the first one and second one. Let us assume. Please substitute equation 2 in equation 1 and follows. You will get the relation. That is mu 1 sin theta c is equal to mu 2 sin theta sin 90 degrees this is 90 degrees. So sin theta c is equal to mu 2 by mu 1 into 1. So you can take two media. Rarer medium is air medium. Suppose let us assume that sin theta c is equal to 1 by mu 1. This is the expression. This expression has one generalized form, that is sin c is equal to 1 by mu. Yes, you can take that. So c is the what we have obtained. Finally, we have obtained that c, it is the critical angle yeah, and mu is refractive index of denser medium. Now it is going to be identified. Mu is the refractive index of denser medium. Suppose the light enters from glass to air, water to air, or some transparent material, quartz to air, quartz glass to air, diamond to air. So we have different transparent materials. So that mu value is going to be identified that. So this is very clear. That is the clear expression. So if you are going to have observation and you feel it is very easy, please take that one screenshot also it might be useful to identify that. Here our consideration is that rarer medium is mu 2 is equal to 1 that is air medium, so that it becomes 1. So, sin theta c is equal to 1 by mu 1. It has been generalized in that form. If you want, you can take that screenshot also, it is useful for you. In problem solvation, you might be having this application. While some problems are encountered in the higher classes also, you need to apply the Snell's law to the denser rarer medium interface. Sometimes you need to calculate that critical angle, calculate that refractive index, whatever it may be, it is useful. So, please, this is very, very important derivation, and confirm that, right. Yeah, what we have taken that relation. So, from that you can calculate this mu also. If you know the critical angle, you can calculate C also and mu also. Now, you are going to get that observation. Variation of C with mu. So, the refractive index of a material is going to be changed, that is mu increases, that C value decreases. Now, simply you will identify this relation. So, if you take that temperature, T, generally temperature, why we have to take the temperature? Temperature is a one parameter which can influence the properties of physical properties of the matter, that is going to be changing, and density is also going to be changing, and speed of light is also going to be changing. As you will find out that T increases, mu value is going to be decreases. You know very well about that. Temperature increases, the density is also going to change, the speed is also going to be changed, that is the refractive index is going to be decreased. Yeah. If the refractive index changes, what about critical angle? Critical angle increases. These are the application type questions. The temperature increases, mu decreases, critical value, that is increases. So, by knowing this relation, so if they have given variation of density, variation of speed of light in that material due to the reasons, it might be temperature fluctuations, whatever, and geographical distortions and any other reasons, we have to confirm as mu decreases, C increases. So, the temperature of a material is going to be changed, its critical value is going to be increased. So, you need to identify and follow this relation, right. Let us have, we use the refractive index and C is the critical angle. Let us take that case studies, different case studies. Calculation of critical angle for water air interface. We have taken that water boundary, air. So, light has been entered from denser to rarer. This is the normal line. So, this is the refractive index. This is the refractive index. They have given refractive index, that is n. It might be having the representation mu also. Theta c is the critical angle, right. So, with respect to the normal, it is going to be 90 degrees, that refraction. Then only you will confirm the incident light ray has been incidented at critical angle. So, you need to get that sin C is equal to 1 by mu. Therefore, given that, what about given mu is equal to 1.33, let us so. Therefore, sin C is equal to 1 by 1.33, let us assume. So, you can have that calculation, that is 100 by 133. Now, you can have that calculations and simplification, you will get that 0.75. So, C is equal to sin inverse 0.75. While you are considering that sin inverse value, you may have that some expectation. So, if they have given the options, you can identify very easily. Sin inverse 0.5, it is about 30 degrees. So, sin inverse 0.75, it might be near to the 45 degrees general in the options. So, if you are going to get that the help of any instruments, you will find out that sometimes you are not allowed to have that calculator or like that, then it is easy to have the some expected value. It is C value is greater than 45 degrees, it is very clear, but the exact value is C is equal to 48.75 degrees. Is very clear. This is the case, we can take that. Now, let us go for another calculation of critical angle for glass air interface. So, the light rays are entered from the glass, glass to air we have taken, this is the normal. The light ray which has been incidented, but the angle of refraction becomes 90, then only we have to consider the incidented angle is critical angle. Yes, this is the 90 degrees, this is the refracted ray, this is the incidented ray. This is the critical angle, that is theta c. So, you can easily identify that. Calculations also simple, you can do that. Here, for glass, if you are going to take that, its a refractive index is 1.5. If you are going to take that glass materials, suppose you can take that different glass material is having 1.5. So, you can take that Pyrex glass and Crookes glass and crown glass, different material, silica carbide glass. So, there may be slight variation from 1.5 to 1.55. So, please have a look in that problems also they have given that crown glass, flint glass, you should confirm, that is 1.5 to 1.55, just you have the idea. That is, therefore, sin C is equal to 1 by 1.5. Now you can take that, yeah, this value goes 0.666. So C is equal to sin inverse 0.66, yeah. You might be having that some idea. Sin inverse of 0.66 approximately 0.7. You know, sin inverse of 0.5, it is 30 degrees. So might be having the near value 40 degrees. So take that. C is equal to 41.8 degrees. It is very clear. Now in case of diamond also you can do that. Please look at the diagram to have the better understanding. Incidented ray, refracted, simply you are increasing that. So we will take that. If I have been incidented at this angle, it is going to be like that. If I am going to incident it, it is going to like that. So the angle of incidence is going to be changed at a particular angle. You might be having that 90 degrees, angle of refraction 90. So it don't like that. Again, if you are increasing above the critical angle, it might be reflected into the same medium, that is total internal reflected. Reflected ray. Yes, it is very clear. Very increasing. These are the different cases we have to study. We have to observe that. So let's go for diamond also. Yeah, yeah, that is very clear. So its critical angle is going to be calculated by knowing the refractive index of the diamond. It is going to 24.4 degrees. So for the diamond, you know, mu value 2.42. So sin C is equal to 1 by 2.42. Now you will find out that sin C is equal to might be 0.413. So C is equal to sin inverse 0.413. It is less than 30 degrees. Why? It is 0.413 is going to be less than 0.5. So it is going to be less than 30 degrees. Very clear. The angle is 24.4. In the given options also, you can easily identify that in entrance examinations especially. Right. Problems based on the critical angle we will discuss. So from basic definition, the critical angle is the one, the angle of incidence is equal to the critical angle, then the angle of refraction becomes 90 degrees. So look at the given problem. Yes, the critical angle is the angle of incidence in denser medium for which the angle of refraction in the rarer medium becomes it's 90 degrees. So you can find out that from the basic definitions they are framing the problems. So look at this one. Yeah, R is equal to 90 degrees. This is a rarer medium and denser medium. This is the case we have to consider. So next problem. relation between the refractive index and critical angle. This is the correct option what we have derived. So, in the next classes also we would like to discuss the problems based on the critical angle and the refractive index of a medium. Please have the continuous efforts to get the better improvement. It might be very useful for your higher classes and entrance examinations also. Thank you very much. Have a great day.